successful shuttle fly out through 2011, and then Orion, all of the large structures for Orion pass through Michoud. So we always affectionately say that, without Michoud, there is no Orion. So everything from the launch abort system down through crew module adapter hardware, the crew module itself, the conical adapter, the jettisonable fairings, the thermal protection systems on the aft end of the heat shield, all of those large pieces of hardware come through Michoud. So Jim is going to talk specifically about some of the articles that we currently have in work. We do have hardware in work for Artemis 3 through 5 currently. In fact, these pieces of the crew module here are Artemis 5 assets. And so I'll pass it off to Jim. And if anybody has any questions, you can certainly stop me or Jim all along the way, and we'll be glad to answer whatever you have.
All right, good morning. Thanks, Tim. Like Tim said, I'm Jim Dahl. I'm the production operations manager here at Michoud for Lockheed Martin. Just to kind of walk you through the production area, the big blue tool you see here is the universal weld system. It's a self-reacting friction welder. We do put the Orion spacecraft on the turntable here and on the grid. You see some of the components. This is Artemis 5. It's pretty close to being completed. The article you see here is the barrel section. It's actually sitting teacup down, and it's basically a barrel section welded to an aft dome. The other components that you see a little bit deeper into the space is the conical section. You can see the cutouts for the windows. And a little bit further is it's a little bit more obscured, but that is the forward section. It's a tunnel and a bulkhead. And so the remaining welds that are required for Artemis 5 is to take that tunnel and bulkhead section and weld it to the top of the cone. And then those two pieces get welded to the top of the barrel, and that's what will constitute a completed Artemis 5 crew module. And although we refer to it as a crew module, it's the crew cabin structure. It's the structural piece of the crew module. And the net shape afterwards, of course, is covered with thermal protection. So there's composite panels that go over the top, and a heat shield, a composite heat shield, and the AFCO TPS that's applied to the bottom. And that's what makes up the overall shape of the crew module. We do have a video clip running, and that shows the completed crew module. That was a previous crew module that was built here, was Artemis 4, and it shows the cycle of the team completing that and then loading it into its cargo container.
How many crew members?
4. We do have some samples here if you want to take a closer look. This is an AVCODE billet. It's just a generic billet. This is what gets adhered to the bottom of the spacecraft to protect the crew during re-entry. Just a couple of fun facts. The temperatures that these materials see are really extreme. So the temperature of the sun is roughly 10,000 degrees Fahrenheit. The bottom of the crew module with the AVCODE applied will see about 5,000 degrees. These are samples of welds. This is a tack weld before a full friction weld, what you see here. And when we're done friction welding, there's a couple of holes that are left that we plug with a different type of friction weld. That's called a plug weld. This is the actual plug itself. And this is the finished product after it's plugged. Of course, this gets machined off. This nut and then the backside gets machined off to create a smooth surface similar to this. And that's what closes out the crew module.
What questions do you have?
What's the alloy of this made of?
It's an ablator material. Several constituents, resins, cork material, and
I'm so sorry.
fine
I didn't mean to do that. I'm sorry.
And this is not the as flown configuration.
Okay.
Yeah, these get shipped down to Kennedy Space Center, and they get custom machined and fit and bonded on the aft of the heat shield.
And as Tim, of course, we talked the crew module here, but as Tim said, all large structural components either come through Michoud or they start here. So we kind of talked over it. I usually like to talk to the banner that's in the back. It's a little hard to see from here, but the launch abort system, the large pieces of structure, the fillet that make kind of the conical section of the launch abort system, the ogive panels, those come here. We do mechanical assembly to them. We do electrical harness fabrication and installation. We also do some testing for composite structures. Behind you is our test area. We've done structural qualification of hardware for Orion and that test fixture and those test fixtures. Crew module we covered. The CMA, we fabricate composite panels for the CMA in a different part of the factory. Composite layup, they're honeycomb sandwich structures, and we do test those here for acceptance. And then the conical, if you're able to see a little bit deeper, there's a cone sitting in the back. That's the Artemis 3 cone. That's what adapts the spacecraft to the top of the rocket. So we do similar type of work to that, testing of it, mechanical assembly, and harness installation.
I got a question. How many of you have been here before? You have?
I have.
Great. Glad to have you back, and glad to have all you here to start with. So far, what do you think about this place?
Amazing.
This place is amazing.
Yes.
When I started my career a long time ago, walking around in this building, I was amazed. And for the first couple of years of my career, I walked around kind of like y'all. And so I'm very glad that I was able to spend my career doing this. I wouldn't trade it for anything. But I'm glad you guys got to come. You're going to see some other things that are truly, the stuff that we do in this place is really amazing. And I know y'all are here for the Super Bowl, but this little you're not? Well, I'm glad you're here because the stuff that we do in here is amazing, and very few people know about it. So, it's up to you guys to spread the word about all the great things that we do here.
I have a question. What have you seen as far as the production difference between Artemis 1 and what you're working on in 5? What's changed along the way? Can you repeat the question on everything?
The question was, what's changed between Artemis 1 through Artemis 5, and what have we seen? So naturally, there's lessons learned with every test, every mission, and we flew in 2014, and we flew again on the Artemis 1 mission, and we learned some things in each one of the test missions that occurred in between those actual flight missions. And we've been incorporating those lessons learned as we move forward, certainly in order to ensure that Orion remains today the only exploration-ready space vehicle.
I'll give you a little bit more detail on the crew module itself. We had a ground test article for crew module. We did a lot of the learning, to Tim's point, on that ground test article early in the program. So far, our structural test article, which was another initial crew module, through Artemis 5, still working on Artemis 5, absolutely no defects. So we learned those lessons early on the weld, and all of those crew modules have been defect-free. So it's a very robust process that we've developed for the crew module. There are some other areas where Artemis 2 has some more stringent environments where we've had to do some redesign and some repair. So we've learned that along the way too. We made those repairs or those design changes to the in that particular case, the launch abort system.
I'll give you another example of lessons that we learned. When we built the first one of these crew modules, and we're just talking the crew module, there's been lessons learned on all the large structures, but just for the crew module, we started out with 33 welds. We made some process improvements, leaned a little bit on supply chain, got that down to 19 welds, and then even more improvements. We're down to now 7 welds. 7 welds and 8 plug welds. So we're always cost conscious. We're always looking to improve processes and reduce the cost overall and improve the schedule to help support NASA's ultimate mission.
If I could expand on his question, and it's difficult because neither of you were working here during Apollo, but what are the biggest changes from manufacturing the crew module for Apollo to where we are now with Artemis?
So I'll tell you a quick story. I had the opportunity
several years ago. I had the opportunity to tour this man that came in here, and we happened to have a crew module in here. And this elderly gentleman was in here with me, and we got up on the ladder, looked down in the crew module, and he seems a lot smarter than most people. And he's talking about how much room there is inside the crew module and so forth. And we go around and tour a little bit more, and then, you know, all of a sudden, when we descend the ladder, some of the folks in here are coming up and approaching this gentleman, shaking his hand and all that sort of stuff. Well, come to find out, I was touring Fred Hayes. So, just the differences: number one, a fully functional launch abort system. That's a huge one. Number two, the overall size of the crew module itself, and the environmental control life support systems that are inside the crew module and support the crew module and the astronauts. So that's two of the biggies.
Other questions? Yes.
So going back to the improvements y'all have picked up as you just worked on the crew modules, since Artemis 5 is in flow, do y'all have a rough idea when you'll be sending that out or finishing up with it?
Yeah, the current plan suggests that late summer, early fall is currently when Kennedy Space Center needs it. Right now, you know, we're preparing the Artemis 2 vehicle. So 3 and 4 are currently down in the O&C at Kennedy Space Center. So as soon as they want it, then we'll ship it to them. Any others? Again, Jim and I really appreciate you guys coming here. We certainly welcome the opportunity to talk to you and have you go and tell the world really about all the great things that we do here that really very few people know about this place. And it's unfortunate because of how awesome this place is. So we appreciate you guys coming. And again, if later on you think of some questions or something, just pass those through Craig, and he'll get them, get them back to us, and we'll get you.
I have a simple question. It might
Yes.
It might be a matter-of-fact question. Why don't we launch from New Orleans? So much manufacturing this year.
Yeah, so that's a NASA question.
What was the question?
The question is, why don't we just launch from here?
Did it show that actually we launched from here?
I think Chandler went over a little bit of that earlier as far as why this site was selected. Surely we were building the cargo planes during the World War II effort and then the Sherman Patton tank engines. But then we acquired the facility in New Orleans when Marshall Space Flight Center director or one was looking for a facility. They had this nice 43-acre facility which was in close proximity to the Deepwater Port, the highways, airports, so it allowed us to get cargo around. But it's been in service for us since 1961, and it's worked out well, getting cargo from here to Marshall Space Flight Center to Stennis Space Center for the testing, and then ultimately out to here.
I'll talk to the kind of the bench strengths. Obviously, this is a huge building, right? So when I started, we laid down external tanks in the building, and they had as it is today, a busy beehive. There was a lot of hardware flow. So that is part of our bench strengths, is the fact that you have 42 acres, you have a large ceiling, a large hook height. You can fit large hardware, large space hardware here. And just to talk about some of our bench strengths, we talked about welding. We do mechanical, electrical, drilling, machining. The machining centers that we have here are the 7-axis machine that we we use to machine the fairings and the cone, there's only 2 of those in the country. And they machine very large spacecraft.
Well, I guess my question was, I understand since we have so much here, I just feel like the logistics would be easier for us to even just launch from New Orleans.
Sure, I'd love that.
Yeah. I mean, I don't know if there's like a weather's, why are we Kennedy and shipping all this stuff over there? Is it more efficient to do it here maybe at some point?
I like your thought process there.
Yeah, what we decided, or what's been decided from the NASA organization, is that we would do the quote-unquote dirty work, so to speak, here, and then all the integration, the clean work would be done down at Kennedy Space Center.
You don't get any
And so that's the
work.
approach. Yeah, well, this is pretty glamorous.
Yeah,
I think this is pretty awesome.
So the crew module seen there, it will be absolutely stuffed with equipment at this Kennedy. Some of the equipment that we do here, we do mechanisms also, we do crew seats, docking hatches, so we ship all of that to Kennedy, and to Tim's point, they integrate all those into the vehicle for to make a final vehicle.
Must be difficult also to transport once the model is done. How do you?
Easy transport.
Is it
Easy.
Well, I guess
Easy.
you
Truck
need to take
or barge.
You need to take a lot of precautions, right?
Oh yeah. Yes, absolutely.
So I guess there are a lot of procedures in place to
Yes.
protect the ship.
So the end of
Absolutely.
that video actually shows the crew module in its shipping container. It is a dedicated shipping container. Just to give you a little bit, yes, you have to bring the crew module over to the VAB. There's enough hook height there to actually put it on the back of an 18-wheeler. As you might imagine, it sticks over the sides of the 18-wheeler, so there are escorts, New Orleans Police Department escorts from this facility out to the state line, and there's a handover of state police that bring it all the way to, as it travels through the states, all the way to Kennedy Space Center. So yes, it's a lot there.
If you're on your way to Disney World, you have to wait behind the convoy. You're not getting back.
That large composite conical adapter structure that you can see behind this barrel section. There's another quick story. Some folks that were headed down to Disney World, like Craig says, several years ago, the road was in essence blocked with one of those conical adapters going down to Kennedy Space Center. So it was a slow go with that super extra wide load. All right, I think you guys have to go, but we really appreciate you coming.
Thanks, sir. Appreciate it. Thanks, Tim. Appreciate it. Very well.
Thank you so much.
Excuse me, sir.
What was your name again?
I didn't catch
Tim.
it.
Tim. T-I-M. Tim.
And
Livingston.
last
Livingston.
Livingston. Appreciate it, sir.
Yep.
Thank for
Appreciate
everything.
you. Hey, nice shoes, man.
And Jim Dole, right?
Jimmy,
I like those
Jimmy
shoes.
Dahl.
That's nice.
Appreciate it. Thanks.